For bond energy, we refer to the amount of energy in a bond, but specifically is going to be the amount of energy required to break a bond. So, before we get into the calculation, it's very, very important to remember that bond breaking is endothermic, while bond making is exothermic. So, what do we make? What do we break the bonds of? The reactants. We break their bonds in order to make products. Very important, because for a chemical reaction, A to B, if I'm going to call it E bond, to break the reactants is bigger to the energy, to the bond energy to make the product, the reaction is going to be endothermic. And of course, the opposite, if it's for exothermic, if the energy of the bond of the product is higher than the energy required to break the reactants, is going to be an exothermic reaction. So this is actually what determines if a reaction is endothermic or exothermic. So you might be guessing how we do calculations for this. Because let's say we have a reaction, H2 plus Cl2 to make 2HCl. We're given the values of the bond and the energy. The bond would be HH, HCl, and ClCl, and these are the values. 436, this is 432, and this is 243. By the way, we're talking about energy, kilojoules per mole. So, if you want to find the energy of the reaction, so the question would be, I'm going to do in another color, calculate the energy change with the reaction. You will need to find the energy, the bond energy of the reactants, the energy of the products, and then to find the energy, I can write it down here, of the reaction is going to be the energy of the reactants minus the energy of the products. Remember, the products are exothermic. That's why it must be the negative value. So why don't you take a moment to try these values? You really need to think about how many of these bonds you're breaking, because notice that we have the stoichiometric ratio to consider. So pause this video, give a value, and then play when you're ready. I hope you gave it a go. It's fundamental to pay attention to the signs, because it's very easy to get them wrong. So the energy of the reactants is the energy, remember, that is taken in. must stay the positive value. We have 436, which is our hydrogen-hydrogen bond, plus just one of the bonds of the chlorine, 243. So it's 679. The energy of the products, we have 2 of the HCl. Sometimes you might have to draw out the formula and check how many bonds you're actually breaking, or you're actually counting. And it's going to be this 432 times 2, so 864. Very important, 679 minus 864. This, remember, if the product is going to be the one minus, okay? Because the value that you get is in total minus 185 kilojoules per mole. So this is important because in the exam questions, this calculation might be 1 or 2 marks, but then you have to, tell you what, or discuss what this value tells you. And if it's negative, it's an exothermic reaction. So we must, check that is reactants minus products, because this determines if it's an exothermic or an endothermic reaction, like in this example. So check the workbook for more of these exercises, and stay tuned for the next one, which is the calorimetry exercise.